Hello and welcome to Studying with Chris, where I try my best to explain topics to help both you and me understand concepts. Today, we'll be going over absolute values and simplifying radicals practice. So, these are some problems that I have written out if you'd like to pause the video and try them on your own. Just note that this question is converting an mixed radical into an entire radical, while the rest of these questions are converting entire radicals into mixed radicals. Now, if you'd like to try them on your own, just pause the video and go ahead. Now, we'll be starting with the first question. So we'll be converting root 432 into a mixed radical. We know 432 is not a perfect square, which means we'll have to divide it into its factors. So 432 is divisible by 16, which means we'll have 16 and 27. Now we know 16 is already a perfect square, so instead of writing it down to its factors of 2, we can just directly write this as 4 squared. Now, 27 can be divisible into 3, 9. Now, same thing with 16. We know 9 is a perfect square, so instead of writing it into its components of 3, we just write it as 3 squared. Now, we have these factors. We can rewrite our radical with these factors in it. So we can write it as 4 squared times 3 squared times 3. Now, since we have two perfect squares in it, we can take these out of the radicand into the coefficient. So we can take out a 4 and a 3. Be sure to take it out as 4 and 3 and not 4 squared and 3, since we are taking it out of a square root. And since 3 is not a perfect square, we have to leave the 3 inside the radicand. Now, we can further simplify this 4 and 3 into 12 root 3. Now, why are our 4's and 3's positive and not negative? Well, since under the context of radicals, we have to take them out as principal square roots, which is just the positive value. If there's a chance that the 4 and the 3 could be negative, regardless, if we're in the context of radicals, they must be taken out as positive. Okay, let's try the next question. Root of 252 x to the 3. Now, before we start, let's define our variable of x. Since 252 is positive, we know whatever the x cubed value is, it has to be positive as well, since we can't have a square root of a negative. So, since a negative value cubed can still be negative, we know we have to set x as positive. So our restriction for x is x has to be greater than or equal to 0, such that x belongs to real. Okay, now that we've defined the variable, we can start breaking it down. So 252 can be written into its factors. This can be written as 4 and 63. Now we know that 4 is also a perfect square, so we can just directly write this as 2 squared. Now, let's break 63 down. We can write 63 as 9 times 7. We know that 9 is also a perfect square, so we can just write this as 3 squared. Now, let's take a look at our x value. We know that if you multiply a variable with a exponent with another variable with an exponent, you would just be adding the exponents. So for example, xn multiplied by xm is just equal to xn plus m. So in this case, we can rewrite x cubed into x squared times x. So these are now our factors of the radicand. So we can rewrite our radical as 2 squared times 3 squared times 7 times x squared times x. Now, we have 3 perfect squares, so we can take these all out. So we'd have 2 times 3 times x, leaving this 7 and this x, inside the radicand. We can just simply simplify this into 6x root 7x. Now, would we need to absolute value this x? The answer is no, since x is already greater than or equal to 0, which means x can only be positive, which means we don't need to find the principal square root, since it's already positive. So we can just leave our answer as this. All right, so let's try this next question. Once again, before we do anything, let's define our variable. So we can see that instead of a square root, we have a cube root now. Now, we know that even if you have cube roots, you can have negative radicands, since you can have a cube root of a negative. Therefore, x can be whatever value it can be. It can be both positive or negative. So we don't need to set a restriction of the value of x. We can just simply say x belongs to real. Now, let's break this negative 64 down. So, using your calculator, you can find out that negative 64 is a perfect cube root. It can be simply written as negative 4 cubed. So, we can just simply write this as cube root of negative 4 cubed times x. Now, we have a perfect cube root, so we can just take this out. Now, we don't need to absolute value it, since there would only be one permissible answer with cube roots, or indexes that are odd. So we can just take this out as negative 4. And since this x is not a perfect cube root, we leave it inside the radicand as x. And this would just be our final answer. Now, let's convert this into an entire radical. So we know our index is 2. So we'd have to bring our coefficient value inside while squaring it. So first we put our negative here, and we'd bring our 2 over 3 inside. So we'd have a radical of 2 over 3 squared times 5, which we can simply simplify this into 4 over 9 times 5 over 1. Now, using your fraction rules, you can just multiply this. So we'd have 20 over 9 negative. Now, why don't we bring the negative inside? Well, if you were to bring this negative inside, your entire radical would no longer have a negative value. So, by that, if we took this 2 over 3 inside, we'd square it, and by squaring a negative, you'd have a positive. So instead of having negative 20 over 9, we'd simply have 20 over 9. Now, this value is drastically different from negative 20 over 9, which is the same as negative 2 over 3 times root of 5. So by taking the negative in, we're completely changing the value of it, which we can't do. So if there is a negative in the coefficient and you have to turn it into an entire radical, you just leave the negative outside. So let's look at our last question. So root 6 of 729 times x to the 10th. Now, once again, before we do anything, let's define our variables. So since x has a even number exponent, we know that x has the possibility to be negative, since a negative times an even number exponent will be positive. So we can only define x as x belonging to real. Now that we defined it, we can begin our factoring. So 729 using your calculator can be broken down into 27 times 27. Now, we know that 27 times 27 can be broken down into 3, 9, and 9 can just be broken down into 3, 3. So 729 happens to be equivalent to 3 to the 6. So we can just write this down here as 3 to 6. Using the property that we mentioned before of xn times xm, which equals to xn plus m, we can note that x to the 10 can be broken down into x to the 6 times x to the 4. So we can just write this down here as x to the 6 times x to the 4, sixth root. Now, since we have 3 to 6 and x to 6, we can just bring these values out. So we'd have 3x sixth root of x to the 4. Now, is there anything else that we need to do for this question? The answer is yes. Since we define x as being belonging to real, x has the possibility to be negative. And since our index is even, x has a possibility to be both positive or negative. So we need to absolute value our x to ensure we're following the principal square root rules. Now, what about the x in the radicand? Well, that doesn't really matter, since x is to the fourth exponent, which means even if x was negative, the value inside the radicand would still be positive. So we don't need to worry about that. Now that we absolute valued our x, we know that this answer will be positive regardless, since even if x is negative, we'd have a positive value on the outside. So we can just square out our answers. That is all from me. If you have any questions, please send me a message. Thanks for studying with me.